How are you? So for this experiment today, we will need a freezing water, and it has to be a pure water. The impurity naturally helps crystals to form around, and that's why we're using pure water. And we're supposed to put the bottles in the freezer for 2 hours and 45 minutes. However, I have a few bottles and some of them froze while the other were okay. So I'm gonna try this bottle of water right now that I just took out of the freezer, and it's frozen, but it's not solid. So I'm gonna tap it to the table and see what happened. Oh, so you could see how water became crystallized and got water. So this experiment worked. Now I'm going to take some ice. I'm gonna take some ice. I'm actually gonna put it here so you could see it. Take some ice. I'm gonna take one of this water and pour it over the crystals. Didn't work with this one, so I'm gonna see if that will work. This water will work. It worked yesterday when I tried. Today it didn't. It's supposed to build, oh, if you could see, it builds a little bit of a crystals. So it's building the crystals. I tried yesterday, it worked, but today, for some reason, and then another experiment where we pour water in the water right here. I'll take another one. Where we pour our freezing water, and then I'm gonna pour some ice on it, and the ice is supposed to crystallize it, which didn't happen either. No, yesterday this experiment really worked, but when I put some freezing water, it's supposed to crystallize around when I put ice. Well, it's doing it a little bit of it. Well, some of our experiment worked, and the other experiment actually is supposed to work, because I did try yesterday and all 3 experiments did work. I think today, for some reason, even though I used pure water and those 2 different bottles, my temperature probably got lower, but as we could see that we created super cool water in the bottle. So let me explain you at least what happened. So you put a bottle of water in the freezer, so it's still liquid when you take it, but by the second you push it, like I did it, it turns into slush. Okay, so this illustrates how super cold water liquid defy freezing with the temperatures below a freezing point. When water freezes, the molecules come together in a crystalline structure. Water molecules as ice have less energy together water molecules as ice have less energy than water molecule in liquid form, and therefore from liquid water to solid water, molecules will lose heat energy. Also, that means when you tap on freezing water, it warms up the rest of the water. In addition, when you add super cold water, which it speeds up crystallization process even more, and it's called snap freezing. And then this is when I tapped the water. The freezing temperature of water is 32 degrees Fahrenheit. As the temperature goes down, water molecules moving faster, and as the head temperature goes up, and as the temperature goes down, molecules move slowly. So we're supposed to have actual crystallization around the ice, and we're supposed to build the crystals, but I think that the other bottles of water were a little bit more frozen than the other bottle for some reason. I don't know, I guess when you put it a little bit farther away in the freezer, it freezes faster, but I did try by instructions. So I guess our experiment worked partially. I'm sure if I keep trying, I would actually achieve this result, because yesterday I did have all these three parts of experiments worked. Okay, so I hope I explained you the crystallization form in a simple way, and thank you for teaching this, for having me in your class. It was an amazing opportunity to learn chemistry, and I loved it. Thank you. Have a nice day.